Okay. William, what is the absolute value of negative 40?
40.
Perfect. Okay. Passion, what is the absolute value of 230? Nope. 230. Absolute value is going to be always positive for these. It's like the washing machine. It washes away the negatives. So if there wasn't one to begin with, that doesn't put one there. It just washes away negatives. All right. All right, we talked about this yesterday. If I've got absolute value of x equals 3, Wade, what are my answers to that? What numbers could x equal there?
Oh, that's right.
If I do absolute value of the x and it gives me 3, what numbers could I put there? I could do 3. There's another one. Okay, x equals negative 3 also, right? Because if I stick it in the absolute value washing machine, it washes away the negative. I'd get positive 3. Okay. All right, we talked about one of these just there at the very end of class yesterday. What happens if I've got absolute value of x equals negative 5? Then your absolute value washing machine is broken because it didn't wash away the negative, right? So that doesn't happen, so that's no solution. Okay, and then Shay, what about absolute value of x equals 0? What number could I use for the x there? Just 0. And there's no positive and negative of 0, so that just have one answer, right? So you have 3 options for absolute value equations. They can have 1 solution, 2 solutions, or no solution. Okay, and if you want to think about when that happens, 1 solution happens whenever your absolute value bars are equal to 0. 2 solutions is going to happen whenever you're equal to any positive number there. And then no solution is going to happen whenever you're equal to any negative number. Okay, questions here? All right. Okay, we're just going to solve some problems pretty much today. So let's remember how to solve a regular equation first, okay? Because if you can't solve a regular equation, you're going to struggle on the absolute value equations. So, Passion, what do you think we should do on example 6?
Do you add 7 to 11?
I do. So I'm going to add that 7 there. So I'll have a 2x left on this side. What do I get over here? 18.
And then you divide 2 by 2 and 18. And you get 9.
X equals 9. I saw this whenever we were doing the pretest. Some of you were just like writing 9x. It's x equals 9. Okay, make sure you keep that equal sign on that line the whole time. Okay? All right, very good. Any questions on that? I'm hoping that this is something you remember how to do. Example 7 is basically the same equation. I just put absolute value bars around my 2x minus 7. So when we see absolute value bars equal to a positive number, we know there's 2 possible answers, right? The stuff on the inside of this could equal 11. I could have 2x minus 7 equals 11. Or, what else could it equal? What else inside of those absolute value bars would give us 11? If all that stuff on the inside equals negative 11, I'd also still get 11, right? So, what we're going to do for absolute value equations is once we get the absolute value bars by themselves, which they are in this case, we are going to split it into 2 equations. So you basically, this is like a tricky way math teachers came up with of making you have to do the problem twice, right? That's not the only reason that it's here, but it does make you have to do the problem twice. So this is the same as what we just did, right? Exactly the same as what we just did. We would just add that 7. 2x equals 18. Divide by 2. X equals 9. All right. I'm showing every step here. I don't care if you show every step, but if you are missing these, you need to show the steps. All right. What I find a lot of times, and I saw this some on the pretest from some of you also, is you're like, oh, I know how to do this, but then you just make a jumbled mess out of it because you try to write down as little as possible. So if you're really good at it and can do it without showing a lot of work, that's fine. But if you're getting the wrong answers, we got to back up and show our work. Okay. And I will not allow you to turn in this assignment with just an answer. If you're going to photomath every single one of these, you're going to at least write down the steps that photomath gave you. Okay? I know photomath will solve every one of these. If you're going to photomath every one of these, you're going to at least write down the steps that photomath gave you. If you just give me the answers, I'm not giving you any credit. Okay? I would not suggest photomath in these, although it's not a, I think I gave you the answer key to this one anyway, but, it's not a bad idea to check your answers if I don't necessarily have it, but please don't photomath everything, because I know it'll do it, but it's not going to help us in the long run. So, over here, really solving this equation, same steps as what we've done before. We just have a different number over here. So we're going to add 7 over here. Let's see, Jason, what do we get when we do negative 11 plus 7? Negative 4. What's the next step I would do, Jason? Very good. And what answer do I get? Almost negative 2. So 9 and negative 2. All right. I have decided for this course I'm showing you Desmos tricks from the very beginning. I would not do this if you were in an honors class. I probably wouldn't even let you use a calculator on this if you were in an honors class. But I want us to have every trick we can possibly have when it comes to being able to do this. I don't want you doing this like on the assignment. Once again, if you just put the answers, I'm not giving you credit. You got to at least show a little work, all right? So if you need to check your answer for an equation, any equation, okay, what I'm going to do is I'm going to do f of x equals left-hand side. You can either use the absolute value bars or you can do ABS 2x minus 7. Okay? There's also absolute value bars down here if you want to use that instead. But if you just type ABS, it's absolute value. And then we'll tell it g of x equals 11. Okay? So if I look at graphs 2 things, if I see right here, I got negative 2. That was one of my answers, right? Now, it does have an 11 right there. You're using the x because we know what x equals, right? And then over here, you got a 9. Okay? This will work on every problem. It'll work on even more complicated problems. And in fact, there are some that are so complicated that I have decided it's the only way we're going to do the problem. These you should be able to do by hand also. But you can check your work with that. All right, so let's keep going. Oh, here I've done the same thing I did on the last problem. I have given you a regular equation and then an absolute value equation that kind of is similar to it. So let's just worry about this regular equation first. Who can tell me how to solve this one? Everybody's panicking because they see a fraction, I think. It's not really a fraction. What should we do first? What do you think? We are going to multiply both sides. It's not the first thing we're going to do. Okay?
Do we add the 2 to the 8 first?
Almost. We got to subtract because we got to do the opposite sign. So we're going to subtract that 2 first. Right? So that gives us x over 3. You're a step ahead of me. Yeah, you're a step ahead of me. Right here we're going to get 6. But then, like Alvin told us to do, we multiply both sides by 3. Because what's happening there is like I got a 3 on top and bottom and it cancels, right? The multiplying by 3 and dividing by 3 undo each other. So that just leaves my x over here, and like Carlos said, I get 18. So that would be my answer for that problem. Now, example 9 is going to be similar. Example 9, we don't rewrite this at the beginning. We don't make it like positive 8, negative 8 at the beginning. Because before we can make this positive 8, negative 8, we've got to have the absolute value bars have to be all by themselves. So what we're going to do is, like this piece right here, we got to get rid of the stuff that's not on the inside of the absolute value bars. So it's similar to this last problem. So what I would have to do first is I would have to subtract 2, just like we just did. And then that would give me absolute value of x plus 5 divided by 3 equals 6. Okay, here. And then, again, I've got the stuff inside of this absolute value bar. The 3's not in there. So I need to get rid of it before I start thinking about positives and negatives. So I would need to multiply both sides by 3. So that would be absolute value of x plus 5 equals 18. Now, at this point, everything on that left-hand side is inside of my absolute value bars, right? So what I need to do, I didn't mean to get rid of that altogether, but I did. What I need to do is I need to make this 2 separate equations. So I'm going to have absolute value of x plus 5. Oh, wait. I actually don't want the absolute value bar. Just x plus 5 equals 18. And I'm also going to have x plus 5 equals what? Negative 18. Okay? Aiden, how do I solve the first one? Very good. What do I get? 13. Let's see. KT, what do I do for the second one? Subtract that 5. What will I get? Negative 23. Okay, so I'll have 13, negative 23. If I want to check this with Desmos, if I want to check this with Desmos, I would do on one side, I would do absolute value. Here, I'll use the bars. You guys might like that better. X plus 5 over 3 plus 2. And then I would put the other side, I'd put 8 down here. And then what can be tricky about using this is sometimes you got to kind of zoom out. But I got negative 23 right there. And I've got, oh, can't see it from my pen. Got 13 over here. So it's the same as what I got. So you can use that to check if you need to. Okay, questions so far? Okay, so steps for this. I waited until we've done a couple. You have to isolate the absolute value first. What's it mean to isolate? It's got to get it all by itself. There can't be anything else on that side of the equal sign, right? This is really important. Okay? Never distribute into the absolute value bars. Somebody's going to do this. I know you will. There's somebody out there. Don't let it be you that does this. Look at example 11. Don't write this down because it's wrong. Somebody is going to try to do this. Right? 20x minus 40. Some of you wanted to do that, didn't you? Like you said, I was like, oh, that would have been me. I would have done that. So, don't. That is not correct. Absolute value bars are not the same as parentheses. You cannot distribute, right? For that. Once you get once you get that absolute values isolated, you're going to split the equations into two, one positive answer, one negative answer, and then we need to check our solution for that to see if it works, okay, into the original problem. Now, I did not plug it back into the original problem. I typed it into Desmos to check. Either one of them works. I'll show you how you plug back in on this next one, so you can do that as well. It's kind of important that you check it at least one way, because I think we should run into, we're going to run into some where we don't get an answer, okay? So, let's look at these problems. This first one, okay? Actually, I probably shouldn't make my line quite that long, because the first thing I need to do is I need to isolate that absolute value. So this has got to be by itself. Right now, I have a -3 over there with my absolute value bars. So, Passion, how do I get rid of that -3? I got to add 3. All right? So now I've got absolute value of 2x plus 6 equals 16. Okay? Have I isolated the absolute value now? Yes. What do I do next? 2x plus 6 equals 16. Or what else? 2x plus 6 equals -16. Okay? So, Ayla, how do I solve that first one? Very good. That'll give me 2x equals 10. What do I do next, Ayla? Very good. And what will I get for my answer on that one? 5. Okay. Then I need to do the second one. Sailor, what would I do first on that second one where I've got 2x plus 6 equals -16? Good. What is -16 minus 6? -22. And then Sailor, what's the last step on that? Divide. What does that equal? -11. Okay. You need to check your answers one way or the other. Desmos is easier. If we go over to Desmos, one way that I could check this would just be to do the absolute value of 2x plus 6 minus 3, and then do 13 over here. And you can see I'm getting -11 and 5, right? So that's one way to check. Another way to check is to plug in the number. So if I do absolute value of 2 times 5 plus 6, actually let me use the absolute value bars. I think that'll be easier for you guys to follow. Absolute value of 2 times 5 plus 6 minus 3. I get 13, which is what I'm supposed to get, right? And I could go back and change that 5 to a -11 and see I also get 13. So you need to check your answers, and we'll see why on this next problem that we do, I think. Okay, questions so far? Okay, all right. Okay, first thing we need to do on this problem is isolate our absolute value. So that's this stuff right here. We got to get it by itself, which means we got to get rid of that 4 and we got to get rid of the 23. What should I do first? Okay. When you're solving equations, it's kind of backwards from order of operations. Like, if we were doing order of operations, we multiply or divide before we add or subtract. But we're kind of going like the opposite way because we've got to undo the things that we're done. So we're going backwards. So you're actually going to add or subtract first. So on this one, So we have that plus 23, we need to subtract 23. So that's going to give us, we'll have 4 absolute value. I don't really need to have pink. Absolute value of 5x minus 10. This is gone. Equals negative 20. All right. So I still have that 4 though. I got to get rid of that 4. How do I get rid of it?
You subtract it still?
Not subtract either.
You divide it?
We divide because it is right beside of the absolute value bar, right? It's not 4 plus the absolute value. If you had a plus sign there, you would subtract it. But it's right beside it, which means it's multiplied. So to undo multiplying, we've got to divide. So we would divide by 4. And the reason that works is because 4 divided by 4 just equals 1, which goes away, right? 1 times something goes away. So we have 4 right there, gone. Now we have absolute value of 5x minus 10 equals negative 5. Okay. So there should be something that seems a little weird to you about that, but I'm gonna keep on working like we're not catching it. That should seem a little weird though. Okay, so if we continue, we'd have 5x minus 10 equals negative 5, and we'd have 5x minus 10. 5x minus 10 equals positive 5. So I would add 10. 5x would equal 5. I'm out of room, but I'd divide by 5. So I'd get x equals 1. And then over here, do the same thing. Add 10. 5x is going to equal 15. X equals 3. Alright, so I got 1 and 3. Okay, let's flip over here to Desmos and check to see if it's right. Oh gosh, I don't really want to get rid of that. That's a mess. So I got 1 and 3. If I type in, let's just do where we replace it. 4 absolute value of 5 times 1 minus 10 plus 23. Did I type that in right? I took the original equation. Let me get rid of all this stuff. So I got 1 and 3 as my answers, right? I just typed in a 1 where that was at. So that's everything that you have on this side, right? Except for I replaced the x with a 1. I'm not getting 3. Okay? Let me go back here. Let's try the other one. Times 3. I'm not getting 3 there either.
Is this supposed to be like a negative after?
No.
Or equals?
Not the way that I'm doing it here. We would just plug this in to see if it does equal 3, and it's not working. It's because we had that negative 5. So if I check this the other way, if I do f of x equals 4 absolute value of 5x minus 10 plus 23. So if I put the left side of the equation here, if I do g of x equals 3, I've got this. Do they ever touch? They don't cross. Alright? Alright, so the reason this didn't work out, if I go back to what I had, is this right here. I told you something should look weird to you right here. Right here. Oh, gracious. Flip back over here. Okay, right here, something should have looked weird to you. Is this negative 5? Can absolute value ever equal negative 5? No. Absolute value cannot equal a negative number. So what we should do, as soon as we see this right here, as soon as we see it happen, we should put no solution. These answers right here are not right. It's easy to miss though. Sometimes you're like so on track of solving these equations and you're on a roll, that you forget. That's one reason it's important to check your answers, because if you check your answers, you'll be like, oh, I didn't get that right. Why didn't I get it right? And then you can look back for that. But if you see this happen, as soon as you see the -5, now, I couldn't tell that from up here, right? Because I didn't have a negative number up here. You got to wait till you get the absolute value bars by itself. You at least have to do that part of the equation first. Because if I have something like absolute value of x plus 2 minus 7 equals -2, can that be true? It can. Because absolute value bars aren't by themselves right there. If I add the 7 right here, absolute value of x plus 2 equals 5. And that can be true, right? So you've got to get absolute value bars by themselves first before you can tell if it's going to be a no solution. So you have to do the first part of this equation no matter what, all right? Once you get it to the absolute values, if it's a negative, you're just going to put no solution. Does that make sense? It's easy to miss these. It's easy to forget to check those. All right, here's the last part that the state of North Carolina says that we have to do. I know how to do these by hand. Can do them very well by hand. I don't think we're going to be able to do them very well by hand because it's kind of complicated. We got to do, let me just show you. You don't even have to write this down. Just watch, okay? Because we're not even going to try these by hand unless you really want to. This is video, and if you want to. All right, so let me show you what you got to do by hand. You got to do absolute value of x plus 5, or well, not absolute value. To do your two equations, you've got to do x plus 5 equals 3x minus 7, and then you got to do x plus 5 equals negative 3x minus 7. It's not that bad. I just feel like we're going to mess it up, so we're going to do it the other way. But so then I would subtract the x. 5 equals 2x minus 7. I'd add my 7. 12 equals 2x. I'd divide by 2. 6 is x. Right? But over here, I'd have to distribute that negative, which I feel like we're going to have a really hard time remembering to do. So negative 3x plus 7. And then I'd have to add the 3x. I have to subtract my 5. 4x would equal 2. Divide by 4. X would equal 1/2. So I'd get 6 and 1/2. I'd also have to check these answers to make sure that they're right, because one of them may not be right, the way that I've done the problem. We'll check with Desmos here in a second to see if they're both right. So that's how you do it. You got to use, but when we've got the x over here, it makes it more complicated. So if you see this, is perfectly fine with me if you go ahead and go straight to Desmos. You're not going to see a lot of these like on your homework. I think I might have put a couple on them. Those are the only ones you don't necessarily have to have work for. So if you have equals and you got x's over here, you can go straight to Desmos. Otherwise, I want to see some work, because what they do a lot of times on the exam is instead of asking you for the answer, they ask you, they show somebody's work and ask where they messed up. So like you have to know how to do it by hand and not just on the calculator. So we need to know how to do some of these by hand, but some of them will, the calculator be good enough. If that's okay with you guys, I can make you do all these by hand if you really want. All right, so what we're going to do for this, and this is just, I've already been doing this, is in Desmos. So whenever we get to, in fact, go ahead and get your computers out and pull up Desmos, because you're going to use this some to check your work and to do your problems whenever we get to the assignment. And this works for any equation. It works for all kinds of equations. Sometimes if you have a really complicated equation, it makes it hard to find on the graph. But I could take something that I don't even know how to solve, and I could use this method, and I would get the answers if I were able to find it on the graph. So it's not just absolute value that this works for. So what we're doing if we use Desmos for this is we are taking whatever the left side is, and we're going to call that our f of x. And then we're taking whatever the right side is equal to, and we're calling it g of x. You can use different letters if you want, doesn't matter, but f and g are just pretty standard. So f of x is going to equal the left side of the equation, absolute value of x plus 5. And then we're going to do g of x equals the right side of the equation, 3x minus 7. Ooh, look at this. I got 2 answers when I did it by hand, right? And I told you we need to check them. Because, what were my answers? They were 1/2 and 6, I think. Does this look like it crosses twice? No. And absolute value, when you have absolute value, it's going to be that V graph. We're going to talk about that more whenever we do graphing with these. And 3x minus 7 is just a line, so it's not like this is going to turn back up and graph hit somewhere. So I've only got one answer for this. What is the answer? It's 6. All right. So the blanks that you see here on these notes are going to tell you look for the intersection of the two graphs. The x coordinate of the intersection is your answer. So my answer for number 12 is just x equals 6. Okay? These are the only type on the assignment that I'm okay with you just putting the answer, because I want you to do these on Desmos. Okay? If you want to do them by hand, just like for some mental practice, go right ahead. But you don't have to. All right, try the next one on your own. See what you get. Freeze the screen. So type that into Desmos on your own. If you're ever curious about the difference between honors and regular, I would make honors do this by hand. I would not let them use Desmos. I don't think any of you are planning on math or really heavy science careers. If you are, when I'm suggesting doing things by hand, you might want to try it, because you're going to have this stuff. You also might want to try to do really well in here so you can take stats or pre-cal next year. I might even suggest pre-cal if you're wanting to do math or sciencey things. If you don't want to do math or sciencey things, then you're good enough to know how to do this on Desmos. Okay, what are you guys getting? 1? Okay, let's see. I've typed it in here. Over here. 1. It's your x coordinate. I realize they're both 1 here. That makes it easier, right? But it's the x coordinate. So x equals 1 should be your answer. If you did that by hand, you'd get 2 answers, and one of them would be what we call an extraneous solution. It doesn't work when you plug it back in. Okay. Okay, we good here? All right, that's the last one, right? I think. Okay. All right. So we've got a pretty good amount of time. Decent. I hope that you'll be able to get this done in here. All right. This is your assignment homework if you don't finish it, but I'm hoping that you will get most of it, if not all of it, done in here. You are welcome to use Desmos on this, but you need to be showing your work on all of the problems except for Oh, never mind. I didn't even put the hard ones on here. Show you work on all the problems. You can use Desmos to check your answers, though. In fact, I'd love for you to use Desmos to check your answers instead of using Mathway, or I actually did post the answer key to this, I think. I would like for you to use Desmos to check, because you can use Desmos on the exam, right? So you can actually use that on the exam to check your work, whereas Mathway or the answer key is not going to be available. So keep that up. But please be on Desmos. You know, it makes me nervous to have you guys all with computers up, but I can trust you, right? I can trust you. Is there anybody in here untrustworthy? Wade?
I should be playing games on the computer.
Not much.
Yeah, she knows.
So don't you do it twice? I have to do it. I can't do another thing.
The right hand side does not have absolute value bars. So over here when you have yes. So on that, because it's absolute value bars, this will be one of these. If you have to do it again, well, with the negative. Right, because if it doesn't have the absolute value bars, you did not put it. And that's how you're going to get it.
What?
Let's see.
What did you say, Passion?
Don't start.
Oh, no, never mind. Yeah,
Anybody want these
Instead of
cherries?
using Mathway.
No, no.
You said show me which type in. Oh, okay. Those work. Your numbers got 19 and -7. Yeah, those work. It's okay to get negative. Right, because what you can't. William, I think, has a question he asked. I think is really good for me to address. It is perfectly okay to get negative answers, right?
On
So
this
like,
one?
let me give you an example where you'll get a negative answer. 5 minus x equals 3. Okay, so if I do that, 5 minus x equals 3, and 5 minus x equals -3. So minus 5 minus 5, negative x equals -2, x equals 2. Over here, minus 5 minus 5. Oh wait, I don't get a negative answer for that. Make that a plus.
If I get 0.
Zero's fine, and it usually means you'll only have one. Well, not always. If you get absolute value of something equals 0, you'll just have one answer. Sometimes you'll get like 0 and 7 as an answer. Yeah, that's fine. And so x equals -8. Like I got 2 negative answers here. It is perfectly fine to get a negative answer. This is okay. Right? What is not okay is to have 5 plus x equals -3. So whatever your absolute value bars is equal to, this right here is the problem. That cannot equal -3. Because this is the washing machine, and whatever's in the washing machine is washing away the negatives, right? So if the washing machine's washing away the negatives, that negative right there can't be there, right? So your answers can be negative, but you can't have absolute value of something equal to a negative. Okay, so if that happens, you're doing this one.
Can you go over 2?
Oh, you can do it.
No,
Okay.
remember.
Alright, the way that, if you
Hey,
want to
well,
check
guess
in
what?
here.
Figured it out. All of it. I'm not trying to shut it right now.
But what I just said.
Whatever you want. Whatever you want. I want pay too.
Inside, the one inside. Okay, so, the absolute value bars are they buy themselves. Like, on the outside. I do, but it's on the other side of the